Hello, welcome to Human Factors in AI. It's a Coursera project. My name is Kavita Ryali. I'll be presenting this topic. Let's go on to the problem definition. The problem of IT ticket classification, especially for edge data centers, have a huge impact to the industry. I'm taking the same one as my previous course in terms of the problem definition. An accurate and quality identification of the problem and speedy resolution can stop multiple high-profile incidents if done in a timely way. Most of the classification today is done manually as it is not mainstream sites. And this comes with being prone to human errors. The volume of tickets are increasing and it is becoming quite costly, hence some semi-automation, a way to look at the problem will streamline the handling of the issues. There are multiple areas of classification for tickets as mentioned in the bullets below. Classifying the incoming tickets accurately, which is unstructured data, text-based on these models, is a difficult task. So with that, moving on to the model architecture. The classification model aims to classify tickets per problem definition in the previous slide. It will also be used to better identify safety-related incidents. We will be using classification models such as NLP, natural language processing, to classify the incoming tickets. And to reduce the possibility of misclassification, which could happen because it's text-based, we will explore different classification models such as the naive-Bayes classifier and also BERT, which uses a word piece tokenization in which it provides different weights to the different terms or words that we identify. Special emphasis will be given to identifying safety-related incidents and more weight to be given to safety-related words for the incoming tickets. And also with more time, more data tickets will be coming in and it will improve performance of the system. Let's look at the user experience and interaction design. This model aims to classify incoming tickets to specify categories for edge sites. Users will enter the ticket descriptions as features in a text form and the model will compute and classify the tickets. Since there is dependency on the model to better identify safety-related tickets to avoid potential major incidents, there needs to be some level of manual intervention when a safety-related ticket gets flagged. A user will have to triage and make their own final decisions to assess the severity and priority of the safety-related tickets. The model will not automate the process fully and in terms of classifying the tickets, but assist humans and the users in the sites. Let's look at the data privacy considerations. The data will be anonymized to an extent that the ticket is used to classify the category and not reveal names of users who entered the ticket information. This way we will maintain the privacy of the users and not allow the system to trace back to individuals or specifics about a particular user. For better management of overall ticket and related safety incidents, data will be segmented to understand insights for better decision making. The data will be aggregated in such cases and anonymized to specifics of any user. Anonymity will reduce bias in the system. Key PII, that is personally identifiable information, will be encrypted and stored this way. Data archival policies and purging will be followed to store only data that is relevant and required for aggregated insights and not individual information. Finally, we will look at the ethical considerations. The weights and word tokenization in the model will be visible so the user will know how the classification was done. There could be bias introduced in the model in several different ways, and one of them could be by identifying categories and safety related words in the text in tickets. This could be the model based on the models. This could lead to some errors if incorrectly identified. It may take some additional iterations to get to correctly identify the right category and classify the tickets accordingly. The next way the bias can be also introduced is how the data is being labeled using either Mechanical Turk or by humans that could cause errors in classifying accurately. Since the tickets are entered using free-form text, combination of words selected could have some bias and lead to incorrect classification of tickets. So, humans cannot completely rely on the model and rectify it frequently. However, a human intervention cadence of triaging to specifically look at high-profile safety-related incidents can prevent unwanted major incidents and avoid death in certain rare cases. So this was my project. Thank you.